In our last lesson, we learned how to prove triangles similar for looking for congruent angle pairs. We also discovered that similar figures have congruent angles and proportional sides. To find the scale factor, we took the side lengths of the image and compared them to the side lengths of the preimage. We're looking at a ratio. We were dividing them. Today we'll use a scale factor to find the missing side lengths of triangles. We will also find missing angle measurements. So remember the previous big ideas we were working with, that corresponding angles in similar figures are congruent. To find the scale factor, we take the lengths of the image and compare them to the preimage. And if we're finding a missing length, it was the preimage times the scale factor equals the image. So let's look at a few practice problems. Here we have two triangles that are similar to each other in the givens. We would like to find the scale factor. So remember, how do you find the scale factor? The scale factor is defined as taking the image lengths, comparing it to the preimage lengths. So we have three pairs of lengths we need to compare. Here's our image lengths, here's their corresponding preimage lengths, and we want to simplify them. So thinking about simplification, we talk about the common factors, the greatest common factors that we could divide out from each number. And so if we think of 72, well, that comes from 8 times 9, and 32 comes from 8 times 4. They have a greatest common factor of 8 could divide out. 27 comes from 3 times 9, and 12 comes from 3 times 4. They have a common factor of 3 you can divide out. Our last ratio, because we have a decimal in the numerator, might be a little bit tricky to think about the common factors to divide out. So we think about the denominator that might help us. 26 comes from 13 times 2. And I could use 13 to make 58.5 by multiplying that by 4.5. So technically they do have a greatest common factor of 13 we can divide out. So for dividing out those greatest common factors from each ratio, what will we be left with? We have 9/4, 9/4, and then 4.5 divided by 2. Well, could we take this last ratio and do something to it to make it look like the previous two? We could multiply the numerator and denominator by 2, because 2 over 2 is equal to 1. We're not changing the value of the fraction, just how it's written. So 4.5 times 2, well, that's 9, and 2 times 2 is 4. Guess what? That's 9/4. Now, if you didn't think about the greatest common factors to divide out and just grabbed the calculator and did your divisions, you notice that each ratio is simplified to 2.25. Guess what? 9/4 is equivalent to 2.25. You found the scale factor. How could you verify that you do have the correct scale factor? Well, let's do a check. By definition, we know the preimage times the scale factor, which I'm using SF to represent it, equals the image. So if I took 32 and multiplied it by 9/4, do you have the match of 72? Well, remember, we're multiplying fractions, you multiply across. So we have 32 times 9 over 4. And we know 32 comes from 4 times 8. 4 times 8. Notice how you have a greatest common factor of 4 in the numerator and denominator you could divide out. Then you're just left with 8 times 9, which is 72. So again, you started with 32 in the preimage, you ended up with 72 in the image. That checks out. You could do the same thing with any other of the preimage lengths, multiplying it by the scale factor, whether it's written as a decimal or a fraction, to see if it results. So 12 times 2.25 is also 27, and 26 times 2.25, or your 9/4, is your 58.5. Again, verifying that we have the correct scale factor for our situation. Let's take a look at another set. Here we have similar triangles, and if you notice, we have a pair of vertical angles that are congruent that we can mark. That will also help us set up our scale factor comparing our image to our preimage. So how can we find the scale factor? Well, we have the image of 8 matching with our preimage of 20, and our image of 11.2 matching up with our preimage of 28. So just like we did before, I want to think about, do these numbers have greatest common factors that we can divide out to simplify our ratio? Well, we know 8 comes from 2 times 4, and 20 comes from 5 times 4. Therefore, there is a 4 as a greatest common factor that we can divide out. So our ratio on the left-hand side, 8/20, really simplifies to 2/5. Now we're comparing 11.2 to 28, and I know 28 comes from 4 times 7. Can I multiply one of those values by something to get 11.2? Well, I could use 4 times 2.8 to make that happen. So technically, there is a greatest common factor of 4 we could divide out. So that would be 2.8 over 7. And we could try simplifying that as well to rewrite it so we no longer had a decimal in our numerator. Now, some of you might have just grabbed the calculator and said, well, 11.2 divided by 28, what is that equal to? And you got 0.4. Well, guess what? 2/5 is also equal to 0.4. So we have our scale factor of 2/5 or 0.4 for our problem. To verify that this is correct, we're going to take the pre-image and multiply it by 0.4 to see if we get our image lengths. So our pre-image of 20 times our 2/5, if we wanted to do it that way, remember multiplying across for your fractions, 20 times 2, and we know 20 comes from 5 times 4. Notice how you have a greatest common factor of 5 you can divide out, so 4 times 2 is 8. And remember, your 8 for the image, 20 for the pre-image, that checks out. If you wanted to use a decimal equivalent, for example, and you took your 28 times 0.4, you got back your 11.2. And again, those are your corresponding parts for your pre-image to your image. So we know we have the correct scale factor. Well, what if we give you the scale factor? Could you find some missing side lengths for your from your image from the pre-image? So here we know that the scale factor from the pre-image to the image is 3/4. Could you find the 3 missing measurements of the image? Well, again, the scale factor, we know it's a comparison of the image to the pre-image, and that's 3/4. We also know the pre-image times the scale factor equals the image. So let's pick a side length we want to calculate and apply what we know to the situation. So let's say we want to find our side length for D prime, E prime. Well, that corresponds to side DE. DE is the pre-image, so the pre-image times the scale factor should equal D prime, E prime. Well, DE is 14. Our scale factor was 3/4, or 0.75. We're going to multiply those together to see what happens. Well, 14 times 0.75, or 14 times 3/4, is 10.5. That's with your calculator. Now let me show you what it looks like again with your fraction. Remember, you multiply the numerators and the denominators and look to see if you have common factors you can divide out. Well, we know 14 can be written as 7 times 2, and then don't forget you have the times 3 from before. 2 can be written as 2 times 2, and notice there's a greatest common factor of 2 that can divide out. So 7 times 3 is 21, and 21 over 2, that simplifies to 10.5. So again, whether you're using the fraction for the scale factor or the decimal, you still arrive at the same length. When we talk about greatest common factors, that's going to be very important, especially as you go to Algebra 2. Again, that's why we're reviewing that concept. Now we have 2 more side lengths to find. Let's focus on finding E prime to F prime. Again, we take the pre-image and multiply it by the scale factor to get the image. So our pre-image EF is worth 22, and we want to find the new image length. So one way we could do it is using our fraction and take 22 times 3/4 to find E prime F prime. Well, that means we're going to take 22 times 3 over 4. Let's think about this. Where does 22 come from? 22 comes from 2 times 11, then you have your times 3. And where does 4 come from? 2 times 2. Do you have any greatest common factors you could divide out? Sure we do. 2. So now we have 11 times 3, which is 33, over 2. And we can see if we can simplify that more, and we know that would be our 16.5. That would be the length of E prime F prime. Now, if you just grabbed your calculator and took 22 times 0.75, or just 22 times 3/4, you ended up with the same results of 16.5. We have one more length to find, and that is D prime F prime. Again, we take the pre-image for DF, which is 20, and multiply it by our scale factor. That will give us a length of d prime f prime. So let's think we're taking 20 times 3 over 4. So where does 20 come from? 20 comes from 4 times 5 times 3, and 4 can be 4 times 1. And we know that there's a greatest common factor of 4 we can divide out. So we have 5 times 3 in the numerator, which is 15 over 1 in the denominator. And we know 15 over 1 is just 15. So that's our length of d prime f prime. Now, could you have used your calculator to help you find that? We could have taken 20 times 0.75 and gotten 15 as well on our calculator. If we wanted to check our results, we could always take our pre-image, again, times our scale factor to make sure it matches our image. Here's another example. The triangles are similar. Find the scale factor, then fill in the missing sides and angle measurements. Well, if the triangles are similar, we should know from our first big idea from the other day that the corresponding angles in similar figures are congruent. So let's mark the corresponding angles in each figure that should be congruent to each other with colors. And we can see the 3 pairs of corresponding congruent angles. Now that we know the locations of what corresponds to what, we should be able to fill in the missing angle measurements. Now we can focus on finding the missing side lengths. So let's think about what corresponds to the pieces, and most importantly, let's also focus on finding the scale factor. So let's think about the scale factor. Scale factor again is defined as the image to the pre-image. So if I take 16 and compare that to 6.4, we know those correspond because that's along our blue and red angle side of the triangle. And 16 compared to 6.4 is 2.5. Now that we have the scale factor, we can start working on finding the missing side lengths. And we have 2 of them, and I color-coded them as pink and orange. And the way that we can find them is using our pattern, the pre-image times the scale factor equals the image. So if we start working on the pink, we know that pink length in the pre-image times the scale factor should equal 26.25. Our scale factor is worth 2.5. So how could we undo this equation to solve for the pink length? Well, these 2 items are being held together by multiplication. How do you undo multiplication? Division. So we would divide each side by 2.5. That leaves the length of the pink side of the triangle equivalent to 26.25 divided by 2.5. And if we do that, we got 10.5. So we could fill that as our missing side length. Now we're missing the length of the side marked in orange. So how can we do that? Well, remember, the pre-image it goes with is 4.5 times the scale factor should equal that length I marked in orange. So the scale factor again is 2.5. So to find the length, we would take 4.5 times 2.5, and that should give me the length of the orange piece, which is 11.25. Now, to make sure that everything is following our check, we can go back to the definition of scale factor. We could take each of the image lengths divided by the pre-image lengths, and they should be 2.5. So 26.25 divided by 10.5, that should give you back your 2.5. 16 divided by your 6.4 is your 2.5, and 11.25 divided by 4.5 is your 2.5. And we verified that everything checks out. Here's another example. We have 2 similar triangles. So we have the image and pre-image also labeled. Triangle ABC would be similar to triangle what? Well, remember, similar triangles, we can match up with their corresponding angles. So if we know a triangle with 2 angles, we should be able to calculate the missing angle for each. So we know this angle here should be 78 degrees. which means this angle here should be 64 degrees. So angle A goes with angle D, angle B goes with angle E, and angle C went with angle F. Therefore, if we're naming the similar triangles, we would say triangle DEF. Now that we know the names of the similar triangles, we want to start working on finding the scale factor. So again, scale factor comes from the image divided by the pre-image. So what corresponding side lengths go together? That would be our 2.6 and 1.39. So image 1.39 compared to 2.6 gives you this as your scale factor. So unless they tell us to round to a certain place value, I would just leave it as 1.39 over 2.68. If they said to round to the nearest hundredth, we would say 0.52. But it all depends on our problem. So this is the most accurate scale factor, but then we could also represent it by a rounded number as well. So at this point, we have a couple of Desmos problems for you to practice with. So we're going to have you pause here and pull up your Desmos. There are 2 practice problem scenarios to go through, and then I will resume going over the answers for each of those. So on Desmos, your first one says the blue triangle is the pre-image and the red triangle is the image. What is the scale factor? Well, again, we've defined scale factor as the image compared to the pre-image. So, looking at our diagram, we know our image is 3.92 and the pre-image is 2.61. So this is our exact scale factor, and here's our decimal approximate. Once we have the scale factor, we can start working on finding missing length. So could we work on finding the length of segment A prime C prime? Sure we can. We're going to use our pattern. The pre-image times the scale factor equals the image. So our pre-image would be AC times our scale factor here would give us a length of A prime C prime. So here's our exact calculations, and here's our decimal approximate. Now our last question says, what's the measurement of C prime for the angle? Well, we know in similar figures, we have corresponding congruent angles. Angle C prime compares to angle C, and they should be congruent to each other. Angle C is 25 degrees, which means angle C prime would be 25 degrees. Here's a new set. Again, the blue triangle is the pre-image and the red triangle is the image. We want to find the scale factor. Well, we have to remember scale factor is defined as the image compared to the pre-image. Well, our image is 1.8 for our side length B prime C prime, and that goes with our BC 2.51. So there's our exact scale factor. Our decimal approximate would be this. Our next question was, what is the length of segment A prime C prime? Well, in order to work on that, we know the pre-image times the scale factor equals the image. A prime C prime is the image. That corresponds with the pre-image of AC. So if we take the pre-image of 4.59 times our scale factor, that gives us the length of A prime C prime. So here's our exact calculations, here's our decimal approximation. Now, could you calculate the length of AB? So AB is coming from our pre-image. We know that it goes with our image length of A prime B prime, which is 2.68. So let's think about the calculations. We take our pre-image, which is unknown, times the scale factor equaling the image. We need to undo this equation to find the length of the pre-image. So they're being held together by multiplication. To undo that, we need to divide. We're going to divide each side by the scale factor. So that's the 1.88 divided by the 2.51. This is our greatest common factor that divides out. So now we just have to calculate what this value is. So this is definitely one for a calculator. If you take 2.68 and you divide it by the value 1.88 over 2.51, this is the length for your segment AB. Just be careful when you're doing this in the calculator. Notice after your division sign, you have to put a left parenthesis, type in your scale factor ratio, and close it with a right parenthesis. So now it's your time to rate yourself. Drag the points to show how today went. If you want to think of it on your 5-point scale, where 1 means you need a lot of assistance with the lesson to find the missing angles or sine lengths and the scale factor, and 5 being you've got this down perfect and you can do it all on your own. Rank yourself to let us know how you are doing, and we're going to review these concepts again tomorrow.